A transverse wave is one type of wave. So in a transverse wave, in fact, the particles move in a upwards and a downwards direction. So the particles just move up and down, up and down, up and down. But in fact, while the particles move up and down, the wave travels in, or in this example, in this direction. So the particles move up and down, but the wave actually travels perpendicular to the movement of the particles. And a transverse wave has a couple of interesting properties. So a transverse wave has an amplitude, and this is of the vibration. So this is the total amount that any one particle moves from rest position. So if rest position is this red line, then at the most that it travels up is that distance, so that's the amplitude. You can also measure the amplitude here, so from rest, the most it travels is down to that lowest point there. And in fact, these high points and these low points, they both have a name. So shooting over here, we can see that the low point in a transverse wave is called a trough, and the high point here is called a crest. And the amplitude is the distance moved from the undisturbed position, so this kind of baseline position. So the waves are, the particles are moving up and down, but the wave is traveling in a direction. And each wave, you can look at one wave, on its own. So this is starting right at the top here. If I move down to the lowest point, and then back up to the highest point, that is one wavelength. So one distance of an entire kind of wave. So I can draw another wavelength over here. If I start at the rest position over here, and if I move up and down and then back up again, I've got this distance here, and that is one wavelength. So this is a transverse wave. So the particles vibrate up and down, and the direction of the wave travel is in fact perpendicular to that. A great example of a transverse wave is one that I've got just over here, and that is a light wave. So you can see up here that there's a wavelength here of the light wave, and in fact light waves is a disturbance of both the electric field, which is just around you all the time, and a magnetic field. So it's actually two transverse waves traveling together. So light is an example of a transverse wave.